recording here. So we have homework due this Wednesday, which is 6.4, the graphing of sine and cosine functions. So let me go through a few of the because on last Wednesday I just showed you how to graph a sine and cosine. In your homework, there is a few more other questions that is not about graphing, is about the other way. Means I give you the graph, you have to give me the function or the equations. So I'm going to show you how to do those. And then after that, we'll go back to your homework, 6.4 online homework. If you have any, we'll go through those. So if you do have any homework questions regarding with 6.4, please put in the chat room, 6.4, only one section due on Wednesday. So what questions you need to help with, and I have time to do some today. So let me share my screen. And so this is a question that you will see in your online homework, that they give you a graph and they say they want you to find the value of A, B, and C for a sine graph that will have this, that symbolized as this equation here, or this graph here. So in order for us to find this A, B, and C, as you know that A is your amplitude that we're talking about, B is a part of your period, and C is your phase shift, because phase shift is C over B. So and then we don't have a D. That means that this graph doesn't move up or down, so the D is not there. So how do we figure out what is your A, B, and C? This is not, the A is easy to figure out. The reason why I say the A is easy to figure out is because the A comes from the amplitude, and amplitude is actually if you take your maximum and your minimum, and you add them up and you divide it by 2, that is your amplitude. So your amplitude in this case is gonna be your maximum plus your minimum divided by 2. So if you look at for your Y value in this case, if you look at your maximum in this case is 3. Sorry, not max, sorry, wrong formula. Is maximum minus minimum divided by 2, not plus. So so for this case, your maximum in this case is 3. So, and then minus, and our minimum in this case is a -3. So that 2 negative will become a positive, and then you divide this by 2. So that will give us 6 divided by 2. So that will be 3. Now that is your amplitude. That is not your A. So your A in this case can be negative or positive 3. So how do we know this will be a negative or positive 3? Is you look at your graph. So let's say that we're gonna do a graph that if you look at your sine graph, because it's a sine graph that we're talking about. So your sine graph is usually gonna be starting from it's gonna be like a hill and then a valley. So that means that your sine graph in this case will be, if you talk about the sine graph, this is a sine graph we're talking about here, is we will concentrate on just the hill and the valley. So this is what we concentrate on in this case. So we are concentrating on this sine wave in this case. Okay, that means it's go up and then down. So by looking at this sine wave, the blue box that I draw here, you notice that it goes up the hill and the valley. So that means that it doesn't reflect it on the y-axis. So what happened is that your A in this case will be +3. So this is what happens when you talk about the graph. So the sine wave is always a hill and a valley. If you have this, means that your A will be positive. But if the graph is going opposite, means you got a valley and a hill, then your A in this case will be a negative. So that's how you differentiate between if your A is positive or negative. You have to look at what is your A in this case. Okay, so for this case, our A is a +3. Next, we need to figure out is your period. So so in order for us to figure out your period, you look at your the graph again, this blue box, we are looking at one full cycle. So as you know that the period is one full cycle, and this is one full cycle. So I'm going to move the box a little bit, and looks like if I zoom it in, this value is pi over 2. So again, every time when you guys do to do this kind of questions, you only concentrate on one sine, okay, one cycle of a sine wave. So this means that your period in this case will be pi over 2. Okay, because it goes from here and it ends over there. So that will be a period, which is pi over 2. And since we have a formula, so in order for us to figure out b, the formula in this case is 2 pi over b. So what you need to do here is you have to solve for b in this case, based on your period. So we're gonna solve for b in this case. So you know, so as you know that your period in this case is pi over 2 for the graph here. And so this, the formula for period is 2 pi over b. So if you solve for b, then you get your b answer. So we cross multiply here. The pi and pi can be canceled because that is, if you divide pi on both sides, you cancel out. So we can cross multiply. So b in this case is 4. So in this case, we solve for b and found out that b in this case is 4. Next thing we're gonna have is the phase shift. So phase shift means that your graph move left or right. Okay. So if you look back at the original graph here, so if you start point, your starting point, if your starting point is at 0, 0, then your phase shift is 0. That means there's no phase shift. Phase shift only happens when your graph is moved. Like, you know, so this is, let's say this is pi over 2. So if you have this, then your phase shift will be pi over 2. Okay, so make sure you guys know that phase shifts only happens when your graph is, your sine wave is moved left or moved right. Now, since this graph originally is from 0, 0, it moved to the right. So that's the reason why that your phase shift is pi over 2. What happens if you move to the left instead of going to the right? Example, your graph now is at negative pi over 2. Then your phase shift in this case will be negative pi over 2. Okay, and don't forget the formula for phase shift is actually c over b. And the good news for this graph, if I again concentrate on this blue box here, you notice that this graph starts at 0, 0. So it means that it doesn't have any phase shift. So we don't have any phase shift in this case. So in this, since it doesn't have no phase shift, so that means that your C will be 0. Okay, so your answer in this case, so you're going to put all your A and your B and your C into this function. So your function in this case will become, A will be 3. So 3 sine, B in this case is 4x. And since we don't have a C, so that will be your answer in this case. So this is how we do this kind of questions. So again, please, if this question comes up in your homework or your test, please make sure you concentrate on this box, one box. And again, if you move your box to like here, because again, this is also one cycle, right? Or if you move your box over here, then your phase shift you have a phase shift, because since your starting point is not at 0, 0, your starting point is at pi over 2 or pi, then we have a phase shift. So we try to avoid those. Then after you have to perform the phase shift. So we always want to figure out, if you want to draw the box, we always want to figure out the box that starts at the y-axis. So because that will tell us do we have a phase shift or not. That will make your life a little bit easy. But if you want to move your box to another full cycle, you are fine with it. Then your phase shift is then you will have a phase shift in this case. Okay. Let's say if you move the box over here, okay, so then we have a phase shift. So in this case, if you move your box to the purple here, the orange, so your phase shift in this case will be pi over 2. Since we move pi over 2, and the formula for phase shift is C over B. And we know in this case, your B is 4 from the period that you find early on. So the no matter what you move, your period is still going to be pi over 2. So that's the reason why that if your box moves to another full cycle, your period is still pi over 2. So you can't change the period once if you move around. So then if you got into this, let's say you're doing this question, then you need to solve for C in this case. So so in this case, if you want to do it, so you will do pi over 2 equals to C over 4. So in order for us to solve for C, I multiply both sides by 4. So C in this case is 2 pi. So if you want to do the purple one, then your answer will be still f of x 3 sine 4x. Then you just need to minus 2 pi. That's the only thing you need to do for if you want to do the orange one. So again, I really recommend you not to not to move it to the orange one like this. So your answer is a little bit easy. So again, in your test, I take all your answer. Either is 4x minus 2 pi, and if you move your box into here, into the right side, then you'll be 4x plus 2 pi. It's going to be all addition of 2 pi because anything at 2 pi is at 360. You can go back to the original one. So so I really suggest you not to use this. I suggest you to stick with the original ones. Anyone have any questions here with this one? Another type of questions you get is I give you what kind of amplitude and phase shift. You have to write down the equations of this function. So again, we need to know your A, B, C, D, and they will tell you what kind of graph is it. Is it a sine graph? Is it a cosine graph? So the question 10 is a sine graph. So you need to figure out what is your A, what is your B, and what is your C, and what is your D by reading the transformation they have. So the A is easily found by picking up the amplitude. So since the amplitude here is 3, so that means your A in this case will be 3. Okay, so that's the first thing you do is you pick up your amplitude first. Then if it's a negative, then then you will say then they will add if it's reflected on the x-axis. If you have this on, then your A will, then you will get A will become negative. Okay, so this is a little side notes that you guys, if you need to. So sometimes when you do your homework, they will tell you if there is they'll give you all these things and they say reflection on the x-axis. So if they have this, it means that your A has to be a negative. Okay, so for this case, we don't have a reflection on the x-axis, so your A will be 3. Okay. Next thing we do the D because D is easy. The D is based on the translation going up and down. Since this is going down 1 unit, so the D in this case is -1 based on the down units. And now we need to figure out your B and your C based on your period and your phase shift. Okay, so in order for us to figure out B, we need to do period. So period is 4 pi. And the formula for period in this case is 2 pi over B. So what we need to do here is we need to solve for B here. So again, I use this because I can write on it. So in this case, you get 4 pi equals to 2 pi over B. And don't forget this 4 pi is over 1. So we need to solve for B. So what we do is we will move these two around. So B in this case is 2 pi over 4 pi. So every time when you want to solve something in the denominator, let's say your variables is a denominator, you can move, if you have a fraction and a fraction, you can always move these two around. Okay. And again, your pi will cancel out. So in this case, your B in this case will be 1/2. Okay. So your B in this case will be 1/2. Next, we're going to find is your C. So in order for us to find C, C is based on C here is going to be phase shift. So in order for us, since the phase shift in this case is to the left of pi over 4, so left means it has to be a negative, and then it will be pi over 4. So since the question says it's a left shift of left of pi over 4, if it's a to the right, then it's positive. To the left is a negative. And don't forget the formula for phase shift is C over B. And we already found B on the previous period there. So it's 1/2. I just used 0.5. So in this case, we are trying to solve for C in this case. So what we do in this case is, again, normal solving here. So negative pi over 4 is equals to C over 0.5. So in order for us to solve for C, I multiply both sides by 0.5. So in this case, you just need to take 0.5 divided by -4. So 0.5 divided by -4, or divided by 4, you can change. So this is 0.125. If you change it into fraction, this is actually pi 1/8. So C in this case will become negative pi over 8. And don't forget, if you want this 0.5 is the same thing as 1/2. So that's why you got a negative pi over 8 in this case. So that is how you figure out your C in this case. So it's a negative pi over 8. So once you get all your A, B, C, D, what you need to do is you just replace it back into this form, this function, A sine bx minus C plus D. Don't forget it has plus D here. Since the question is asking for an equation, so make sure that you use the y equals 2. Okay. If a question is asking for function, you use f of x. So some of you did your online homework, they mark you wrong is because you forget to put y equals 2 or f of x equals 2. So make sure you guys read the question carefully. If a question is asking for equation, y equals 2. A in this case is 3. Sine B in this case is 1/2 x minus C. C is negative pi over, is it 8 or 12? What do I have? Sorry, just I think it's 8, sorry. So pi over 8. So and then D is -1. And as you know that inside here, you got double negative. One negative comes from the formula. And the other negative is because you move to the left. As you know that double negative will change to become positive. So this is your answer for question 10. So make sure you guys know how to do this kind of questions here, because this is actually easier compared to the one that I showed to you last time, this, the graphing here. So this kind of question is a little bit easier to do. Okay. All right. So this is the end of 6.4 here. Does anyone have any questions for me for your online homework 6.4? Anyone have any online homework question for me for 6.4? Either you can put in the chat room or, ask me now. Anyone? Now, the other thing is extension of your homework. So I've been receiving a lot of extension from you guys for your homework. You think I will open all the, oh, I forgot to do your homework. Oh, no. You think I will extend all your homework? The answer is no. So if you ask extension already and you re-ask twice, that's the most I can give it to you. So I'm not going to give you all the extension you want here. Oh, I didn't do it. I forgot to do it. I'm busy. So I can only extend up to 2 online homework. So if you do want to extend your homework, make sure you don't email me, request right here. So if you want to extend your homework, request your extension. And I can only request up to 2 extension here. So if you already did use the 2 extension, do not ask me for more extensions because I will deny the extension in this case. And also do not forget that if you read my syllabus, I dropped 3 of the lowest online homework score. So that is the only thing I can give to everyone here. So if you ask more than 2 extensions, it's gonna be denying the request. And also I dropped 3 of the lowest online homework score. So make sure you guys start working on your homework here. this is serious here. Your homework does give you points. And I do have a lot of students at the end of semester, they come and beg, oh, I will do the homework. I will do this. I will do that. I was like, aren't that a bit late now? So please do your freaking homework. Do not wait till the last minute to do it, because you guys all, I got lots of emails come on Wednesday because it's due on Wednesday midnight at 10 p.m. I'm not gonna stick around at 10 p.m. because you guys are lazy or push it to the last minute to do your homework. So please do your homework on time. This is something I really want to point you guys to you. This is trigonometry. This is not algebra 1, algebra 2. This is trigonometry. So make sure you guys start working on your homework here on time. Okay, don't wait till the last minute. So anyone have any questions for me here before I start with the new section 6.5 today? And if you do, just ask me after class. So 6.5 is where we begin to graph the other trigonometric functions. So so tangent, cotangent, secant, cosecant, and secant. So we begin to do I do not need to save. This is pretty much basic. So we're gonna talk about how do we graph tangent and cotangent and secant and cosecant graph. So this is 6.5 here. Again, in order for us to graph the tangent graph, I really suggest to use, again, remember last time we used the coordinate x, y. And again, your x has to be in angles, in radian. So what we do here is we're gonna use the unit circle, remember that? And we only pick the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. So we're gonna go back in one full revolution here. So in this case, your x in this case will be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And what we do here is we plug this into here. And again, if you look at your unit circle, your tangent in this case is going to be y over x. So if you look at 0, tangent 0, y over x, if you take 0 divided by 1, 0 divided by 1 in this case is 0. So, so the first case we have here is tangent 0 is 0. And then we do pi over 2. So pi over 2 in this case, I'm going to separate the screen here so you guys can see on both sides here. And I can write that one. So, so pi over 2 is here. So again, tangent is y over x. So this is 1 divided by 0. And as you guys know that anything that divided by 0 is undefined. So this is going to be undefined in this case. And when you look at pi is over here is 0, again, y over x, 0 by d by -1. This is 0. And then when you look at 3 pi over 2, it's going to be y over x. And since your x is 0 or y, a -1 over 0, so this will be undefined. And then when you go back to here, the 360 or 2 pi, you will get back 0. Same thing as the first one, 0 here. So when you draw the graph, for the undefined case, you're gonna use is your vertical asymptote. So all your undefined case is your vertical asymptote. That means that you cannot cross it. So if you want to draw, usually a vertical asymptote is a dashed line that goes vertically. So this vertical asymptote in this case will be pi over 2, and then 3 pi over 2. Because it's undefined on such case. And if I want to go on to the negative side, so we just negative this value. So the undefined case in this case will be negative pi over 2. And then negative 3 pi over 2. So these are your, and then if you want to continue, it'd be 5 pi over 2, 7 pi over 2, 9 pi over 2, and so on. So in order for us to draw this graph, so we got 0, 0, which is right here. Pi over 2 is undefined. At pi, it will be at 0. And then 2 pi will be at 0. Let me draw another one on this side. So this is, oops, sorry, 5 pi over 2. So what we're going to do here is, because we only got 1 point, we cannot draw the graph. So what we do here is we need additional point in this case, because this is not enough. So we begin to use pi over 4, 45 degrees. The reason why we use pi over 4 in this case is because these two are exactly the same. And as you know that when you do tangent, we are dividing your y over x since they are the same. So it's either 1 or -1. So pi over 4 will be the perfect one to use, because when you divide, you get 1 or -1. It's nice. So when you look at this unit circle here, so the pi over 4 that we have in this case will be 1, because when you divide square root of 2 over 2, you get 1 in this case. And then when you do the 3 pi over 4 is a -1, because this divided by negative. So 3 pi over 4 will be a -1. And then when you go to 5 pi over 4, because both of these are negative, and you divide, become positive. So 5 pi over 4 will also give you a 1. And then when you go to 7 pi over 4, because this is negative, don't forget the y value is negative, the x is positive. So you will note what you figure out that there will be a -1. So this will be 7 pi over 4 here. So what happened is that this we can use to draw your tangent graph down. So this is what your tangent graph looks like. Just want to show it to you. So at pi over 4, which is, this is 0, this pi over 2, pi over 4 is right in the middle here. You will get 1. And then at 3 pi over 4, which is a middle of between those two, this is 3 pi over 4, you will get a -1. And then at 5 pi over 4, which is over here, you will get back 1. And then 7 pi over 4, which is in between the 2 pi and the green line, you will get -1. So you notice if you concentrate on just this line to this line, you will get these 3 dots. So what happened is that this is what your sine graph looks like. It looks like your cubic graph. You remember your x cube graph? So it will look something like this. And the graph will never cross on your vertical asymptote. And it will be the same thing on all of those, because this is one cycle. So if you think about -pi over 4, it will be going to be at -1 here. So this graph will also look something like this. So this graph, the purple graph that I draw here, is what we call it as your tangent graph. So tangent graph in this case is going to be very similar to what I just draw here. So all the purple graph that you see. So it looks very similar to a cubic graph in this case. Okay. So usually we figure out what is the period here, because that's important. So remember last time when you do sine and cosine, the period is 2 pi, because it's, you know, the whole thing. So the period for tangent is just from one vertical asymptote to another vertical asymptote. So if you look at these two value, it's going to be from pi over 2 to -pi over 2. So these two negative become positive. So actually your period here is pi. So that means that if you every pi, you will get a new cycle or a new period for tangent in this case. Okay. So so remember last time when you do the period is 2 pi over b. So since the period here is pi, so the formula to find the period for tangent graph is actually pi over b. So do not use 2 pi over b for tangent because your period here is no longer 2 pi, it's only pi in this case. Anyone have any questions for the tangent graph? And then we figure out your domain and range. And so what is the domain for the tangent graph in this case? Now, as you know that domain means your x value. So the only x value you cannot take is when you have the vertical asymptote. So everything is good except for the green dot dashed line. So your domain in this case is all real numbers except pi over 2, 3 pi over 2, 5 pi over 2, and negative pi over 2. So how do we write this is since it starts with pi over 2, so your domain in this case is all real numbers. X cannot be pi over 2 plus k pi, where k in this case is integer. That means that any value for x works except for pi over 2, 3 pi over 2, 4 pi, 5 pi over 2, and negative pi over 2. So this is how we write your domain for this case. Your range is the y value. Since this value goes from negative infinity, if you continue drawing it, and this go to positive infinity, so your range in this case will be all real numbers. Okay. So remember last time when you guys do your starting and ending point, when you do your bx minus c, last time you used bx minus c equals to 0 and bx minus c equals to 2 pi for sine and cosine. So in this case, your starting point in this case and your ending point is still bx minus c for tangent. Then we need to figure out where do you want to start, because it depends on where is your, because we have so many tangent graph here. So usually, some of you ask me which tangent graph we need to start with. I will tell you that we will pick this tangent graph. And the reason why we pick this tangent graph is because it consists of the y value. Remember on the beginning of the time when I call you to do the sine wave, I said goes close to the y value, the y-axis. So that's why this one, we pick this one because it's the y-axis. And if you notice, it starts at negative pi over 2 and it ends at pi over 2. So that's why if you want to find your starting point and your ending point, we will make them equals to negative pi over 2 and pi over 2 because that is where we start and end. And do not forget when you solve for x, the starting and ending point here, we also call this as your vertical asymptote. That means that it's a dashed line. That means your graph will not gonna be crossed over on those lines. Okay. The next thing we're gonna talk about is, remember your A, your amplitude. Okay, your amplitude is absolute value of A. So if your A is positive, you will get this graph. You will get, the cubic graph. So what happens if your A is negative? So when your A is negative, you do not have a cubic graph like this. You will have the reverse cubic graph. So you will look something like this, the brown line that I draw. So this brown line that I draw is when your A is negative, negative numbers. So for example, that this is your A. So if you have y equals to negative 2 tangent x, then your graph looks like the brown one instead of the purple one because it is being reflected on the x-axis. Again, this 2 means that this value is no longer at 1 and negative 1. It will be at 2 and it will be stretched to 2 and negative 2. You guys all right here with this? Questions? Definitely we need some examples. Okay. Flip this around. Anyone have any questions for me? Save this. So this is just the tangent graph. So we're going to do the cotangent graph, which is a little bit similar to tangent graph. And again, we use back the same value, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we're going to use back the same unit circle that we have. Don't forget that tangent is y over x, so cotangent will be x over y. So now you just need to take like 0, you have to take x divided by y for cotangent. So if you take this divided by this, 1 divided by 0, this is actually is undefined here. And then if you go to 90 degrees, pi over 2, it is going to be x divided by y. So it's 0 divided by 1. So this will be 0. And then if you go at the pi, which is on the other side here, so x divided by y, so negative 1 divided by 0, this will be undefined. And then on 3 pi over 2 is x divided by y, 0 divided by negative 1, this is 0. And then back to the 0, it will be 2 pi in this case, will be undefined. And as usual, if you draw this graph, the undefined case is your vertical asymptotes. Again, we always use dashed line. So at 0, you will get a vertical asymptote on the y-axis. And then at pi, you will get another vertical asymptote. And then you get 2 pi, another vertical asymptote. And if you want to go to the negative side, so you just reverse it. So you just do the opposite. So you'll become pi will become negative pi. And then 2 pi will become negative 2 pi. So this is your vertical asymptote for this case, which is very important. And then you do pi over 2. So right in the middle here is pi over 2. You will get 0. And then 3 pi over 2, you also get 0. So, and again, as I mentioned earlier on, you will not able to draw any graph here is because you only got 1 point. So what do we do here is we begin to use the pi over 4, because we always use the trig pi over 4, because when you divide them, it become 1. So anything correspond to pi over 4 is what we try to do. So when you divide these two, you will get 1. And then when you do the 3 pi over 4, because one of them is negative, so this will become a negative 1. And then when you do 5 pi over 4, you divide this is positive 1, 2 negative divided together. And then the last one is 7 pi over 4, because 1 is negative, so you will get a negative 1. So you notice that the 1 and negative 1 for tangent and cotangent is the same. So pi over 4 is right in the middle here. So you will get 1. And then 3 pi over 4 is again right in the middle between the pi half and pi. You will get negative 1. And then 5 pi over 4 is the middle between that, you get 1. And then 7 pi over 4 is the middle here, you get negative 1. So I'm going to use a pink one. So this line that I draw is a cotangent graph. So it looks like a cubic graph that is being reflected on the x-axis. So this is going to be the same as everything. And since this is pi over 2, so this will be negative pi over 2. And then this will look something like this. And since this cross at 3 pi over 2, so this will be crossed at negative 3 pi over 2. You guys all right here? So the pink graph that I draw here is your cotangent graph. Anyone have any questions for me with the cotangent graph? Not finished yet because we still need to continue with this. Anyone have any questions? So we're going to talk about period. So again, the period is measured from one vertical asymptote to another vertical asymptote. So this is your period. So since it starts from 0 to pi, so your period in this case is pi. So again, same thing with tangent. All your periods is pi in this case. Okay. So when you find your period, again, we don't use pi, 2 pi over b, we only use pi over b. So only tangent and cotangent is the only two graphs that we will be using the period pi over b. For sine and cosine and secant and cosecant that you learn later on, the period will be 2 pi over b in this case. Okay. So we talk about your domain and range. So your domain, if you look at this, is all real numbers. X in this case cannot be k pi. So in this case, it means that your x can and k in this case is integer. So that means your k cannot be 0, 1, 2, 3, and -1, -2, -3. Your range in this case, since it goes from -infinity to all the way to positive infinity, so your range in this case is all real numbers. And don't forget the starting and ending point that I show you. So it's going to be bx minus c. Since if you look at your vertical asymptotes here, we always pick one of the period or one of the cycle to figure out. Again, as I mentioned, it's always the one closest to the y-axis. So we will pick this, this period or this cycle here. So because it starts at the y-axis here. So if you look at this, the starting point is at 0, the ending point is at pi. So we will take the bx minus c equals to 0 and equals to pi for the starting point and the ending point. And you try to solve for x here. And don't forget, when you solve for x, all this value will be a vertical asymptote, means you draw the dashed line. And then the last thing we point out is reflection. So what happens if your A is negative? If your A is negative, then this graph will be reflected on, going down to this the other way. Okay, so the red line that I draw. So this is when your A is negative. So if you have A in front here and that number is a negative value, your graph will be reflected on the X. And if it's A is a -3 or -4, then this value will no longer at -1, it'll be at 3 and 4. Depends on whatever your A is. So this is your cotangent graph in this case. It's very similar to tangent. Anyone have any questions for me? I'm going to take attendance now. So go ahead and use the chat room for attendance. Where is my? Yep, attendance time. So please take taking attendance. Yep. The next thing we're going to talk about is your secant and cosecant graph. So we do the secant first. So in order for you to draw the secant and the cosecant graph, you need to draw the reciprocal graph of it. So in this case, if you talk about secant, then we draw about your cosine graph. Because secant is the reciprocal of cosine. And if you remember your cosine graph, it will be a value, right? Cosine is a value. So at 0, it will be at 1. At pi over 2, it will be at 0. At pi, it will be at -1. At 3 pi over 2 is at 0. And then at 2 pi, it will be at 1. So this is your secant graph, is a big cosine graph. This is a big valley, and then it continue going a big valley. So this is your cosine graph here. So this is your cosine graph. Okay. Yes, when you draw your secant graph, you need to draw your cosine graph first before you draw it. So what is going on with the secant graph in this case is you have to do two things: your horizontal asymptotes and your vertical asymptotes. Your horizontal asymptote, which is the one that goes horizontal, is bound on your amplitude. So in this case, since it goes from -1 to 1, so your horizontal asymptote in this case will be bounded on 1 and -1. So you will have y equals to -1 and +1. So that is your horizontal asymptote. And then on your vertical asymptote is where this graph crosses on the x-axis before you move up and down, which is D. So remember, sometimes your graph, you move D, up and down. So this is before you move your graph up and down. So you notice that when you look at your x-axis or x-intercept in this case, you notice that it will be crossing at pi over 2. So this is the x-intercept. And it also cross at 3 pi over 2. And if I want to continue with this one, this will be a 5 pi over 2. So you notice that again, your your vertical asymptote in this case will be all odd. 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. And if I want to go for the negative one, it would be a negative pi over 2. And then this will be a negative 3 pi over 2. So this is all going to be over on kind of like odd 1, 3, 5, 7, you know. And so your vertical asymptote in this case will be x equals to pi over 2 plus k pi, because it's all odd in this case. So what we do next is, now you find out that when you draw this, it has a little box. And if you look at the cosine graph, this whole box, it has a whole mountain, right? A whole mountain. So your secant graph is a reflection. So you reflect this whole mountain and it will touch at 1. So the purple graph that I draw is a secant graph. And then this fellow is a valley. So it will go side upwards like that. And then this will be a mountain or a hill. And this will go this way. And then this will be going downwards. And don't forget, it touch, it's not going to cross on your horizontal asymptote, it will touch it. Okay, so it's touching that. So it's going like up, down, up, down, up, down like this. So this graph, the purple graph that you see here, is your secant graph in this case. So that's the reason why you need to draw, every time you draw me a secant or cosecant graph, you need to draw me your horizontal asymptote, which is a red line, and the vertical asymptote, which is a green line. And then you have to draw your cosine graph and then you reflect. Now, one thing I want to point out here is that when you draw me this vertical asymptote, like let's say your cosine graph is this one. If your vertical asymptote cross in the middle like this is wrong. Okay. Usually when you have a whole mountain, your vertical asymptote is always bounded by the whole thing. So your vertical asymptote will never cross in the middle like this. So if you find out that your vertical asymptote cross in the middle like this, something is wrong. Okay, usually it goes the whole hill or the whole valley. It's not going to be just partial hill and partial valley like this. So if you got something like this as your vertical asymptote, this is going to be a wrong case. Okay, just want to point out to you guys so you guys know what's going on when you do your secant and cosecant graph. Okay, you want to have any questions with this before we continue? Again, class, some of you do not give me your real name, so I do not know who you are. So if that is not your real name, not in my register, or that's not your name, I will mark you absent. Okay, so make sure you guys know how to change your name in your Zoom here. So some of you, I have no idea who you are. So I think that's one person in last, I don't know who the heck are you. So I just mark you absent. So make sure you guys change your name so I know who you are, or you just type David Liu's present. If you're going to use Ayub, okay, I do not know who. Some of you, I have no idea who you are because I haven't met you yet. So once we get this, so again, as usual, we're going to figure out your domain. So your domain is all real numbers. X cannot be pi over 2 plus k pi, which is the same thing as your vertical asymptote. So if some of you will figure out, if you know your vertical asymptote, you should know your domain because they are very similar. Range in this case, now because the range, if you look at the purple graph, it grows from negative infinity. And then you go all the way till -1, and this is included. That's why we use a bracket here. And then after that, if you look at the other purple graph, it starts at 1 and it goes to infinity. Okay. Now, this, as usual, we have the start point and the ending point. So, but for secant graph and cosecant graph, we got two. We got the start point. This is a start point. We got the we got the start point. Let's see, we got the start point, we got the middle point, and we got the ending point. So this is all using Px minus C. Okay, so that means that this graph will have you will have based on your asymptotes. So what you do here is that when you have the starting point in this case is based on your asymptote. So since it starts, if you look at this, this is where negative pi over 2 is where you start. So again, we're going to take this cycle. Okay. And if you look at this, there are three green lines, three vertical asymptote. So you start it from negative pi over 2. So this is a middle starting point. And the middle one is pi over 2. And the ending one is 3 pi over 2. And the period for this is going to be 2 pi, same as your cosine over b. And as usual, when I bring up the negative, if you remember what happens if your a is negative. So what happens if your a is a negative number? So this purple graph that you draw that goes up, it will reflect down here. And if it's a reflect down, it will goes up. So the orange graph that I draw here is your secant graph if your a is negative. That means you got a negative secant graph. So you just need to reflect up to down, down to up. You guys all right here with the secant graph? You want to have any questions for me? Right. So the next thing we're going to talk about here is your cosecant. That's your last graph. And since cosecant, the reciprocal is sine, and the sine wave is a hill and a valley. So when 0, it starts at 0. At pi over 2, it goes up to 1. At pi, it goes to 0. And then at 3 pi over 2, it goes down to -1. And then at 2 pi, it goes to 0. So this graph is your sine wave. Sorry, it's a bit bad because oops, sorry, wrong way. To go down first. So don't go up here like what I just did. Should be going down, then up. Oh my goodness, this is really bad. I am so sorry. So as usual, like secant graph here, your cosecant graph has a horizontal asymptote and your vertical asymptote. And the horizontal asymptote is bound on the 1 and -1. So you will have a horizontal asymptote at -1 and 1. That means that it will, the y value here. The vertical asymptote is where it crosses on the x-axis. So before the d, like what we did over here. So if you look at the x-axis or x-intercept, you find out that you got 0 here. The next one is pi. So this is going to be a pi. It's hard to draw it without. 2 pi is the next one. And then 3 pi if you want to continue with the following. And then if you want to do the opposite, will be -pi. And then -2 pi, and so on. So in this case, your vertical asymptote in this case is x equals to k pi, where k in this case is integer, like 0, 1, 2, 3, 4. So as I mentioned earlier on, like secant, you will notice that this, I'm gonna use a pink one. This will be a whole hill. So your cosecant graph will be gonna be kind of like reflections of a hill. So you go down to the valley, and again, it touched at 1. And this is a valley, so this is going to be go up as a hill. And then this is a hill, so this is a valley. So, and then this is a valley, so this will be a hill. Again, don't forget, this graph will not cross on your vertical asymptote, means you cannot, it's not a parabola. It looks like a parabola, but actually it go parallel with the vertical asymptote. So again, class, when you draw me the secant and the cosecant graph, you have to draw me the vertical asymptote, the green line, and the horizontal asymptote, the red line, and the sine graph, black, or the cosine graph, depends on what graph is it, secant or cosecant. And then after you do the reflections, the pink one or the purple one based on what you have. Please do not erase this in your test. Some of you who do the test, do not erase this. Leave it there. Some of you want to erase the sine wave or the cosine wave. Do not do that. Just leave it there. Okay, because that's how I see your work. Okay, so again, we do the domain. Sorry, this is really light here. So the domain in this case will be all real numbers. Again, it's based on your vertical asymptote. X in this case cannot be k pi, because you cannot be 0, 1, 2, 3, 4, and negative 1, 2, 3, 4. Your range is the same range as your secant graph, means it goes from negative infinity to negative 1 included because it touches there, and then 1 to infinity. So it goes from this side to up there. Your period again is going to be 2 pi over b. Okay, and then as usual, this again is very similar to secant graph. So since it starts from this here and then goes up, so you will have three. Oh, that's my grade. So we will use this whole period to figure out your starting and your ending. And since it has a middle, so you will have a starting point and a middle point and ending point is where you use your bx minus c equals to 0. This is where you start. The middle point is equals to pi, and then the end point is equals to 2 pi. A little bit different from your cosecant graph or your secant graph. And then the last thing we're going to talk about here is your negative. So what happens if you have your A is negative? So if your A is negative, then your graph will be reflected. So this will go upward. So this red line will be go down. So this is what happens when your A is when you have a negative cosecant graph. And then this is going down. So this will be going upwards. So make sure you guys understand this. This is it's a lot, I know. As I told you, this class is a lot of things here. And yes, Sari was like, can I need to memorize this? I will say that once you get hang on this, you practice a little bit more on it, I would recommend, yeah, you will get home on all those things. So I would say that you probably need to practice, right? Because this is your first time seeing it, some of you. So so it's like, you know, so I would really strongly you guys to practice this. Without any practice, I will tell you will fail my test. Definitely will. You will get an F in the test. So this is how you do your graph for sine, tangent, cotangent, secant, and cosecant graph. So we talked about all this already. So so let's do some examples in this case. Okay, so the first example that we have for this question here is asking us to do y equals to -2 tangent 3x. Okay, so usually when we do tangent and cotangent, we do have phase shift, but we try not to do some phase shift and the D because that's sometimes a bit more difficult to do it. So the next one has a phase shift. So in this case, your A in this case is -2, and your B in this case is 3. So this is your A, this is your B. Same thing like sine and cosine that you did on the previous section. You don't have a C, or in this case 0. Your D, we don't have it in case it's 0. So now a lot of students will ask me about amplitude for tangent and cotangent. For tangent and cotangent, amplitude does not exist because amplitude only exists for sine, secant, cosecant. That means it's the max minus the mean divided by 2. Since if you look at your tangent graph, your tangent is going like from one end to another end. You notice that there's no maximum, there's no minimum. The maximum is infinities, right? So for all your tangent and cotangent graph, the amplitude does not exist, but it does have a period. And don't forget, the period is no longer 2 pi over b, it's just pi over b. So that means your period in this case is pi over 3. Okay. So do not forget that period for tangent and cotangent is based on your vertical asymptote. That means the 2 vertical asymptote here, that's your period. That means from here to here, the period is pi over 3. Okay. Phase shift, we still use the same formula, C over B. Since we don't have a C, so we don't have phase shift. Again, phase shift means you move your tangent graph left or right based on the C. You will do an example with a phase shift in this case. So when you do tangent and cotangent, this is normal what you do sine and cosine, but you need to do additional place, which is a vertical asymptote. Your vertical asymptote has to take bx minus c. And if you remember the tangent graph that we draw originally, it starts from the first end, which is negative pi over 2. And it ends at positive pi over 2. So when you do your vertical asymptote, you have to use these two numbers. So your bx minus c is inside your parentheses. So in this case, it's just 3x. And you start from negative pi over 2. You solve for x. So this is your starting point. And your ending point in this case is 3x equals to pi over 2. So because originally it starts at negative to positive pi over 2. So we begin to solve for x. So I would divide this by 3 to get rid of this 3. Or the same thing as multiply by 1/3. So that means that this tangent graph will start at negative pi over 6. And same thing, when you divide this by 3, you will end at pi over 6. So your graph, if I draw your graph here, your vertical asymptote will start at negative pi over 6. And it will end at pi over 6. And that is a vertical asymptote. Now, as you know that we need 2 cycles. So in order for us to figure out what is the next one here, you take this pi over 6 you have, and you add it with your period. And your period in this case is pi over 3. So if you add this this value with the period pi over 3, you will figure out what is this next vertical asymptote. So this is going to be pi over 2. Okay. And then this one will be negative pi over 2. So this is how you figure out your vertical asymptote. And then right in between your asymptotes here, you will have 0 here. So that's 0. So right in between here, it will be at 0. And how do we figure this one out? You just find the average. So what is 1/6 plus 1/2 divided by 2? So we just use some kind of like doing the average, the middle point. So 1/6 is this number, a bunch of decimals, divided plus 1/2, which is 0.5, divided by 2. So this is going to be pi 1/3. So this is pi over 3. And this will be negative pi over 3. So this is usually how we figure out is we just do the middle of it, like the median of it. Okay. So tangent graph used to go like this. Okay. And don't forget, this is 1 and -1, right in the middle here. But now if you look at your A, the A plays a very important role. Your A in this case is a -2. So this is the one that a lot of students make mistake in my test. So what happened is this one will be at 2. And usually it's a positive here. So this fellow will be at negative. So this is right in the middle of this. So that will be pi over 12. And then this will be pi over 12. And this will be at -2. It will be right over here. So don't forget, because of a negative, your tangent graph is no longer like a cubic, but it's going to be the opposite of a cubic. And that 2 pull our 1, the amplitude become 2, kind of like an amplitude type. So your graph will look like the purple one. That is what your answer in this case. So it's very different from sine and cosine. If you remember, when you do sine and cosine, you have to draw the coordinates, right? The basic coordinate, the 5 basic coordinates point, and then you do the 5 final coordinates point, and then you do all those things. So for tangent and cotangent, you do not need to figure out the 5 basic coordinate points. You just need to figure out that tangent is going. You need to figure out your vertical asymptote, and you need to watch out for your A in this case. So that is very, very important in this case. So the purple graph that we have here is your tangent graph in this case. And don't forget, in the test, I need 2 cycles. 2 cycles means 2 of this purple line here. So I did 3 cycles here. So in the test, I do need 2 cycles in this case. Anyone have any questions for me with the tangent graph? Which is a bit less work than the other type of graph. So this is how we do the first one. Then we do the cotangent graph. So in order for us to do the cotangent graph, it's kind of the same thing we did in tangent graph, which is same as your sine and cosine. Figure out your A, figure out your B, figure out your C, and figure out your D. So go ahead, look at this question 2 here. Tell me what is your A, B, C, D is. Yep. Anyone? What is your A, B, C, and D?
So A would be like 1.
Which is this one. Yep. B?
X, no, pi over.
Nope. This is, what's number next to X?
Oh, 1, 1, 1.
1. Yep. C?
Pi over 6.
2. That's a 2. Sorry, that's a 2 here.
Okay, okay.
So pi over 2 is wrong. This is wrong. Why is wrong?
Oh, negative.
Yes, don't forget the negative. Because don't forget, origin, this is a negative. So make sure you have a negative. And do we have a D in this case?
No.
Okay, good. So again, tangent and cotangent do not have amplitude. So do not need to do any amplitude here. Does not exist. Period is pi over B. And B in this case is 1. So this is just pi. Okay. Phase shift is C over B. So it's -2, negative pi over 2. And since B is 1, it's over 1. So this over 1 is redundant. So in this case, your phase shift is negative pi over 2. And when you get a negative, it means you move to the left. Some of you was wondering what is this stands for. It means you move to the left, your cotangent graph moves to the left. So make sure you know how to do this in your test. Again, vertical asymptote start with starting point and ending point. And we will use the bx minus c, which is x plus pi over 2. And you have to equal to something. So now you need to figure out your cotangent graph. Originally, your cotangent graph, very similar to tangent graph, but is the other opposite. Can someone tell me what will be the first vertical asymptote that we use that is close to the y-axis? So you start from where? You start from 0 to pi. So in this case, you have to start from 0 to pi. So for tangent, it's negative pi over 2 and pi over 2. This is for tangent. Cotangent is 0 and pi. So we have to solve for x. So x in this case is negative pi over 2. You move this over there, become negative. And x in this case for the ending part will be pi over 2, because when you move the pi over 2, you subtract. 1 subtract half is pi half. So in this case, your tangent graph, your cotangent graph actually starts at negative pi over 2. And it ends at pi over 2. And since your period is pi, so what we do here is, in order for you to find the next one, is you add pi to. So half plus 1, this will be 3 pi over 2. And then this will become at negative 3 pi over 2. So every time when you want to figure out what is the next vertical asymptote, you take the what you have and then you add with your period. Always add with the period that you found here. Then we know what is the next one to draw. And so now this is your all your so now we figure out what is right in the middle. So always right in the middle is always at 0. Middle, so the middle between half and 3/2, so 0.5 and is pi. So this will be also negative pi, so that's the middle of it, and this will be 0. The good news is your A is 1, so that means we do not need to do the transformation of flipping them around or moving them to 2 or 3. So this is still going to be 1 and negative 1 because your A is 1 here. So your graph will look very similar to this cotangent graph because there's no other transformation because A and B is 1. So only transformation is move. So this graph will look so at right in the middle here, pi over 4. So it's between 0 and pi half negative. And then right over here is also pi over 4. There will be a negative 1. So this purple line is your answer for your cotangent graph. And then this one will be following the same. And this one will be following the same. So this is your answer for question 2. You guys all right? How do you figure out your domain here? So in order for us to figure out the domain is you always take this, the one that closest to the y-axis, so pi over 2, plus your period. Since your period is pi, so you just put k pi in this case. So usually this is how you figure out your domain here is all real numbers. X cannot be this. So a lot of students, when you do your homework or your test, they will ask you for domain. This pi over 2 comes from this vertical asymptote. And then the k pi came from your period here. Okay, so this is how you figure out your domain in this case. So you will ask what is a domain? So this is a domain. Anyone have any questions for me on this one? I'll do the domain on the other one too, so you will see it. Let's do the domain of the other one. So this question, what is the domain in this case? So if you look at this, what is the closest one close to the 0? Pi over 6, right? So it would be pi over 6. So it's all real numbers, sorry. X cannot be pi over 6 plus what is your period? Your period is this one. So you just put k next to it. K pi over 3. You guys all right?
put the real numbers and do you put that little thingy
Yep,
before
comma.
it or after?
You put comma x not equals to this pi over 6.
Oh, before, okay.
Yep, k pi over 3. So this is the domain in this case. So make sure you know how to find the domain. It's not that once you got your graph, this is your starting point where it starts, and then the period is the one that figure out the domain. Put a k next to it, and you get yourself a domain. You guys all right? Right. Next one we have is secant and cosecant graph. So as I mentioned, if you want to draw a secant graph, you need to draw the reciprocal of it. Anyone know what is the reciprocal of secant graph? Sine or cosine? Anyone know?
Cosine.
So it's cosine. Do we have any parentheses on the 4x plus 2? No, right? So do not put parentheses on it because it means something with and without parentheses. So with this, can you tell me what is your ABCDs?
A is -2.
Mhm,
B is 4.
mhm.
C is -2.
No.
Mm.
So that's the reason why I told you be careful with the parentheses. If this doesn't have a parenthesis, what does this 2 means? C or D?
C.
That will be your D, yes. So that means we don't have a C here. So in
Why?
this, because the parenthesis is on the 4x.
Oh,
So make sure you, that's the reason why I'm very emphasized on this is because in the, if you put C is 2 or -2 and D is no, your whole graph is wrong. It has the domino effects. So make sure you guys know that if you have parentheses, this will be your C. But if you don't have a parenthesis, then this will be your D. So be careful with, then your parenthesis just right over here. Okay, very important, just watch out for it. Okay, and don't add your own parentheses. What is your amplitude for this case? It's the absolute value of A. So in this case will be
2.
2. The period is 2 pi over B, right? And B in this case is what?
4.
4. So it's pi over 2. So 2/4 is half. Phase shift is C over B, but since we don't have a C, so we don't have a phase shift. Okay. Now don't forget, when you draw the cosine graph, we need that 5 points, right? The 5 original points. Does anyone remember what is the cosine graph for the 5 original points? Anyone? This is what you did in your my 6.4 homework, right? I told you if you doesn't know how to draw a cosine graph, forget about secant and cosecant, sine, cosine graph. You need to know how to do this. What's the first point for cosine? It's the value.
0.
0 what?
Like 0.
0, 1.
Oh.
Up here. What's the next one? Pi over here. Pi over 2, 0. The next one is down here, which is pi -1. The next one is 3 pi over 2 and 0. And the last one is up here, which is 2 pi 1. So this is your original 5 cosine graph. So what you need to do here is you need to figure out your starting point and your ending point. So you have to take the bx minus c, because if you talk about cosine, it starts from 0 and it ends at 2 pi. So can someone tell me what is bx minus c in this equation? 4x or 4x plus 2?
What was the question one more time?
What is the bx minus c for this question? 4x or 4x plus 2?
4x? Just
Yep.
4x?
It is 4x. Again, because that's inside your parentheses. The 2 is your d, so that's why it's not a part of your bx minus c. So again, you have to solve for x. So when you divide by 4, you still get 0 here. What happens when you divide by 4 here? You get what? Pi over 2. So what we have here is you start from 0 and you end at pi over 2. And in order for us to figure out what is the next one, we always take the period divided by 4. The reason why we divide by 4 is because it has 4 quadrants. And the period we found out here is pi over 2. So you take the period, which is pi over 2, divided by 4, which is the same thing as multiplied by 1/4. So that means that you have to add pi over 8. 2 times 4 is 8. So in order for me to find the next one, I have to add pi over 8. So it becomes 0 plus pi over 8 is pi over 8. And then I have to add another pi over 8. So it becomes 2 pi over 8. So 2 pi over 8 is the same thing as pi over 4. So this will be pi over 4. And then I add another one. So 2 pi over 8 becomes 3 pi over 8. And then I add another one with 4 pi over 8, and 4/8 is 1/2. So that's why you get this. So this is how you do your x values here. You have to take the bx minus the starting point and the ending point, and then you always take the period divided by 4 to figure out what you add onto it. How do you figure out your y value? So in order for you to figure out the y value, you have to multiply by a, and then you add d. So a in this case means -2. So you have to multiply this with you have to take all the values and multiply by -2. And then after that, you add 2 to it. So the first number we have is 1. See, the y value we have here is 1. So what is 1 times -2? And add 2. What you get? 1 times -2 and add 2.
0.
Yes. And next is 0. What is 0 times -2 and then add 2?
2.
2, yep. Next is -1. So what is -1 times -2 and then add 2?
5.
Not 5. 4. And then you do 0, and we did 0 already. 0, you get 2. And we also did 1. 1, you get 0. So this 5 final points is what you have to graph it. So you're going to graph this 5 final point. So you start from 0, pi over 8, pi over 4, which is 2 pi over 8, and then 3 pi over 8, and then 4 pi over 8, which is pi half. And the y value in this case is either 0, 2, or 4. This is the 3 values we have. So at 0, you get 0. At pi over 8, you get 2. At pi over 4, you get 4. At 3 pi over 8, you get 2. And pi over 2, you get 0. So it looks like a cosine graph, but instead of going a valley, this is going to be a mountain or a hill. It's because of a negative. So remember, when you have a negative in front, you have to flip it around. And if I want to continue drawing, it will be another mountain. Another mountain. If I want to continue drawing, because I need 2 cycles. So this is how you draw your cosine graph. But do not forget, this question is not drawing cosine graph. This question is drawing what? Secant graph. So once you get your cosine graph, if you want to draw the secant graph, it's easy. You just need to draw me your vertical and your horizontal asymptote. So your horizontal asymptote is the line that the maximum and minimum line. So it will be y equals to 4 and y equals to 0. So this is the highest you can get, 4, right? And 0 is the lowest you can get. And then the vertical asymptote. Now, if you remember what I did on the secant and cosine graph is the x-intercept before D. So now remember D, we have a D, right? You move it up 2, right? So that means that your vertical asymptote in this case is where it is at 2, the D. So on this 2, so everything on the 2, because you move up already, that is your vertical asymptote. So anything that starts at 2, which is your D in this case, because since you move up, usually it's at the x-intercept. Since we have a D, since we move it up 2 or move it down or wherever you move, because we have a D here. So your vertical asymptote will be at this value. And so what is going on with this secant graph is, because if you notice, this whole thing is a whole mount, a whole hill. So the secant graph will be the orange one that goes opposite of it. This one is a valley, so it's going to be go hills. And don't forget, it cannot cross the green line, the vertical asymptote, but it will touch. And this will go like this. And then this will go like that. So this is 2 cycles, so you go up and down. So this is how you draw the -2 secant of 4x plus 2. Before we end, I will ask you for domain and range. Same thing in your task. What is your domain? So a lot of students use back the same trick. Oh, if you look at this, oh, this one starts at pi over 8. So the domain will be starts at pi over 8. Oh, sorry, all real numbers. Oops. All real numbers, x cannot be pi over 8. And then you use the period. Remember, we use a period. K pi over 2. So a lot of students do this. For secant and cosecant, you cannot do this. Tangent and cotangent, yes. Secant and cosecant cannot, because if you do your period, this is your period. From here to here is a period. But if you watch carefully, it has another green line in the middle. So you need to include this. So what do you do with this is you just take your denominator and you times 2. So it's always, so this is for secant and cosecant. So in order for you to find the domain, you just need to do the same thing as what you do in tangent and cotangent. And then what you do is you always take the denominator times 2. So your domain in this case is all real numbers, x cannot be pi over 8 plus k pi over 4. Okay. let's say, so make sure this is always times 2 in your denominator. And this is only work for secant and cosecant. So it would, tangent and cotangent is the same thing, but secant, cosecant, you just multiply by 2. Range, because this goes from negative infinity all the way up to 0. It includes 0. And then it goes from 4 to infinity. So this is how you do your domain and range in this case. So that's it for today's class. If you have any questions, please stay back and ask me. If you do not have questions, you may go. Make sure you put your attendance. Okay. You do have one homework due on Wednesday, which is 6.4. Please start work on your homework. Don't be at the very end here. When we come back, we'll talk about the cosecant graph, how we draw a cosecant graph on Wednesday, and then we'll do the inverse trick in this case. Okay. All right. Does anyone have any questions for me? Please start.